I'm recording this video for my GCSE and A-level electronics students, and we're going to have a look at what makes a good design specification for electronics, and it's going to be based on this document that I've got on the screen here. Now you might say that if it's based on this document, why don't I just give you the document? And I did, or certainly I thought about doing that right at the start. But fairly early on I realised if I give you this document, some people, obviously not everyone, but some people are just going to blindly copy some things without giving much thought to it. And it's far better that I explain these things so then you can come up with your own design specification and truly understand what it should include. So I'm not giving you the document, so if you want to know, if you want to look at the examples, watch the video. Okay? So first of all, I'm just going to cover a couple of things that you want to avoid in writing your design specification. First of all, and we're going to look up here, you want to make sure that you don't include any really trivial details about maybe how the circuit might be built, like, you know, whether it's on a PCB or the number of resistors in your circuit or the fact that you've got resistors or LEDs, or maybe even just saying that you're going to include a single 7-segment display or even 10 7-segment displays if you wanted to go quite crazy. Yeah, I mean, that is that might make it a technical challenge, but it's not really what the design specification is for. So avoid detailing either how you could construct it or the components, unless, for example, it's critical to solving the problem. For example, if you've identified a problem that maybe you're going to have to transmit some music by some optical means, then it might be appropriate to mention that the design specification, one of the points will be that lasers should be used. But, you know, I think that's rather dubious. Generally speaking, don't detail the construction, the components, or how you're actually going to implement things. That comes later. So also avoid subjective criteria. Now, subjective criteria are the sort of things that if you ask two people, you might not necessarily get the same answer. So, you know, like if you say, is she good looking, he good looking, well, that's subjective because everyone's opinion is going to be different on that. Well, there's going to be a wide range of opinions anyway. So if, for example, you say your device or circuit will have a loud alarm, and remember we're later on supposed to be testing this to whether it is actually loud or not, well, you know, what is loud? You know, you want to avoid that. And also actually this point about measuring loudness, we're going to come back to that in a while. Saying that an LED will flash quickly or a motor will run quickly or slowly or whatever, once again, they're very subjective. What is quick, what is slow? Okay, so avoid those. And if you talked about reliability, just by saying it's reliable, that one is also quite dodgy. You can specify reliability in terms of system availability and all things like that, but, you know, that is not a subjective thing. Okay. Also and this is referring now to the loudness, be very wary of specifying anything that you would need to measure, okay? So, for example, if you were not subjective, so if you avoided saying loud and you said 85 decibels, well, I mean, that's quite possible that we could measure that, but only if we had the equipment, and unfortunately in the classroom I don't have a sound meter. Possibly if we went to music, but yeah, I just don't think it's really a very good idea. So through lack of equipment or lack of knowledge about how to use that equipment, or maybe you're using recycled parts. Now, the reason I mention that is because it would be fairly easy for us to actually buy. Say, you know, if it's an alarm, we can easily go online, go to our suppliers and find that one of their buzzers might be specified with a sound output of 75 decibels, whatever, 85, 90, whatever it happens to be. But then again, if you're specifying that detail, really you're just specifying the components, okay? On the other hand, if you were making yourself an audio amplifier and specifying the audio amplifier of a certain amplitude, yeah, that's great and that's really good, but are you going to have the equipment? Are you going to have the knowledge about how to do that? So for many students, probably the majority of students, certainly GCSE, I would say, avoid anything about sound, specifying the volume of sound and the measurement of. Okay. So what things then should you do? So the stuff on the left was what I would recommend against doing, but the things that you should do, you really need to specify how your circuit or your device is going to perform, and maybe its function or operation as well. So in doing this, you need to try to use objective, so not subjective, not like down to personal opinion, but now objective, which two people hopefully wouldn't disagree about too strongly anyway. So for example, if say you've got a motor, like I don't know, it's like a fan or a food mixer or whatever it happens to be, and you say that the motor speed is continuously variable. So for example, it's variable from being stationary up to like a range of speeds, okay, and speeds in between there, that will be continuously variable. In actual fact, because likelihood is, although not certainty, because you could make it an entirely analog system, for many motor control circuits, you'd actually include some sort of digital element somewhere, so it might actually be stepped speeds, but very finely stepped. So the stepping is the quantization error, but don't worry about that. If you're GCSE, just ignore that. If you control a motor and you want to just like go from stationary to like faster and everything in between, then that would be fine to say continuously variable. And the same for continuously bright, change of brightness or something like that as well. If you said that it shall have user selectable modes as well, that is, so long as they can be selected, then it is user selectable. It's objective, it's not subjective. Okay, so, how you select those modes, there could be many different ways. Different switching systems. It might be contact based, so you actually have to press a switch. It might be non-contact based, so you put your hand, waft your hand across some infrared sensor or whatever it happens to be. But they either are user selectable or they're not user selectable, so it's objective. If you look at the mark scheme, both for the A-level and the GCSE, you are asked to use, qualitative and quantitative criteria. Now, the qualitative ones are descriptive criteria, and sometimes this actually causes a problem to people at thinking of them, but actually they're not that difficult. So so long as it's not measurable and describes the function or the operational performance, you should be all right. So if you said, for example, the device must include short circuit protection, so if you have like an accidental short circuit, then it shuts down the power supply. It's got it, okay? It's not really, well, it is measurable to a degree, that one actually, but for our purposes, just saying it either has short circuit protection or it doesn't have short circuit protection, that's a quality of your product, okay? If you said the device, your circuit, whatever it is, would raise a visual alarm, like a visual alert, so like maybe flashing lamp or LEDs or whatever, and an audible alert, which could be like a buzzer, whatever, okay, loudspeaker, when a boiler overheats, then absolutely, it's not measurable. It's not like you can't measure whether it does have it or doesn't have it. It's either it has it or not. So that's a qualitative or a descriptive thing. Now, I've just put this little note in here. If you said must raise a visual alert and an audible alert, personally, I would recommend splitting that into two descriptive or qualitative criteria. The reason being because maybe when you implement your circuit, you might find that you manage to do that one, but that one fails for some reason, or vice versa. If you split them, then you still have achieved one specification point, but if you combine them together and then one of them fails, you've only like half done it, so it becomes difficult to say whether you've actually achieved that criteria or not. If you said something like your product should have an automatic sleep mode, once again, that you're describing something that your circuit must do, so it either does it or doesn't do it, so it's qualitative, okay? Quantitative, on the other hand, these ones are something that's going to be easily measured, and not just like be there or not be there, but actually measured, perhaps using a multimeter or an oscilloscope. So it might be a voltage, or it might be current, or it might be frequency. Or it could be temperature even, but once again, I advise students for electronics projects in my classroom to avoid temperature things because it just becomes inconvenient and a little bit slow as well. It's not to say you can't do it, but it's just a bit of a pain. Okay, so something that you could measure might be like how fast something flashes. So the LED flashes at frequency of say 5 Hertz. So that would be very, very much measurable. Even if you haven't used an oscilloscope yet, it's very easy to learn how to use the ones we have, and you can hook a probe on to say the LED, and then you can see, although you can actually see the LED going on and off, you'll actually also have a little graph on your computer screen which you can screenshot, and then you can put in as evidence that you have measured that, and it does output at that frequency. If another quantitative, in other words measurable criteria, okay, I think I'll call it measurable, is like if you're doing party lights, and if you said your party lights will have at least 12 user selectable modes. So if it has 10, then it hasn't met the criteria. If it has 12 or 13 or 14, then it has, okay. By the way, if you're doing something with modes, you really don't need to have like 12 modes. I can't see that you would, but you know, up to you. Okay, I'll leave that one to you. Okay, let's say if you were doing some sort of alarm system, maybe for safety seatbelts, or maybe a pram or whatever, okay? If it's a safety system, you might want the alert, the warning to come on pretty quickly. So that would be a good thing for a measurable criteria. So, for example, the warning must sound within 500 milliseconds, half a second in other words, of seatbelt being unfastened during travel, okay? And the way we would probably do that, there would be a sensor on the seatbelt. There would be obviously an output transducer, like a buzzer or some other sounder, which is going to make the noise. And then we have the probe on each one. So we'd use an oscilloscope, that thing. Okay, we'd use an oscilloscope, and you'd see a trace going along the screen. Seatbelt in use, seatbelt in use, seatbelt in use, and then suddenly seatbelt not in use, you know, outputs a logic high, or whichever way round it is, and then you'd have another trace following the alarm, so the alarm's off, the alarm's off, the alarm's off, and then the alarm's on, and then latch is on, or whatever it happens to be. So very easy to do with an oscilloscope, and then you can measure the delay, if there is, well, there would be some delay between the seatbelt being unfastened and then the alarm being sounded, and it would be very easy to, with a microcontroller, to do that within half a second, no problem at all. Which actually also brings me to the point that when you do timings like this, you say your program must respond, or your product must respond within a certain time period. Leave yourself a big margin. I mean, does it actually make any difference whether the warning is raised like in 10 milliseconds or 50 milliseconds, you know, if you've got to like refit the seatbelt or whatever? I would say probably not, but you know, it depends on your application, okay? So think sensibly. It might be that the warning must sound within 5 seconds or whatever, if that's what you want, okay? Now, buzzers themselves have a frequency. So typically, if it's an audible, would be an audible buzzer, it's probably going to be sounding at something like 2 kilohertz, so like 1,000 cycles a second. Might be 5 kilohertz, I don't know. We could check that from a data sheet of a buzzer. But then there's no point really in specifying that. If you said something like the buzzer will sound at 2 kilohertz, and then all we're doing there is we're just specifying a trivial detail about the component, and then you'd have to purchase a buzzer which had a 2 kilohertz output. Okay, and I really don't think that is a justifiable thing. Basically, you're not doing this. I don't think I mentioned this earlier. You look, some of these details, like the frequency of the buzzer, might be important to you, but if you over rely on specifying them in your product specification, design specification, just to achieve points, like if you've been told that you've got to have like, I don't know, 5 design specification points, and you say it must have 5 buzzers, 3 LEDs, 2 inputs, which, you know, something like that. Just basically just over relying on just counting up components and things, or the trivial details like the frequency of a buzzer, to achieve the points in the mark scheme, then I'm going to mark you down, okay? Because that's just not what the mark scheme's meant for. So on the other hand, if you had that buzzer of a certain frequency, sound like bzzz, and then stops, and then bzzz, and then stops, and then bzzz, like that, and maybe it's going on and off, and it's doing that twice, on off, 2 times a second, then that would be entirely appropriate to actually specify that, because that's something that you have control over. On the other hand, actually saying that the the sound frequency of the buzzer, that's just, you don't have any control, because that is self-regulated by the buzzer, which actually does make me think that if, say, you had a piezo transducer, then you actually have to create the signal to drive the piezo transducer, so that would be entirely appropriate if you wanted to specify that as one of your design specification points, especially if it was important to your application. Let's say that you were testing someone's hearing, then obviously you need to, and you're testing like certain frequencies, then that is absolutely key and really important to the operation, the performance of the product you're making. If you're making an alarm for, say, someone who's hard of hearing, or particular age groups, you might want to change the frequency. So then as long as you have control over the frequency, absolutely fine to specify that as a quantitative criteria, measurable criteria. Okay. Now, measurable criteria also have or can have tolerances, and if you look in the mark schemes, I believe in the GCSE and A-level, you have to check. Believe that they ask for some tolerances, okay, where appropriate. So, for example, if, for example, like this, the alarm being sounded after you're under a seatbelt while your car's driving along, 500 milliseconds doesn't have to be exactly 500 milliseconds, so maybe like 600 milliseconds would be perfectly fine, or 550 or 450 or whatever. So you might say like 500 milliseconds plus minus 10%, or whatever you want, okay? So if, say, you've got if you're planning to make, I was going to say made, but you actually do these before you make it. If you're planning to make an electronic game, and it has some sort of game over indicator, like game's over now, you've lost all your lives, or you won to the end, or whatever, and then, so let's say that's like an LED that's going to illuminate for 3 seconds. It doesn't really matter, does it, if it's 3 seconds or if it's like 4 or whatever, but you could, if you wanted, specify a tolerance for that, because when you're doing timing, basically no timings in your product are going to be exact. There's no such thing as an exact time. So there's no such thing as an exact measurement on duration at all, okay? So you can, if you feel it's appropriate, you can add a tolerance as well. So now I've got a load of examples here, so let's have a look. So I've split it up into like power supplies, circuit performance. By the way, when you do this, not splitting, but when you present your design specification points, I suggest you do it in a table, and I suggest or a table or numbered points. It's quite useful. If you do it in a table, you can have like the specification points for like one column, and then another column later on you can then say whether the specification point was met in full, partly, or not at all. So tables work really well because you can copy them later. Numbered lists as well, they could work all right. I don't think bullet pointed lists would be good, but then again, I've just come up with some random ideas, okay? So here's some ideas then. Power supply will output 3.3 volt. That's another way of writing 3.3. Okay, so yeah, that's quite specific, isn't it? Okay, so it's a measurable criteria. It's not subjective. It's it's absolutely fine. There you've got measurable criteria with some tolerance on. The power supply will be able to supply a continuous load at 200 milliamps. Well, easy enough to measure. You can stick a resistor on it so it pulls 200 milliamps. You can use a multimeter to check the voltage doesn't droop. check the current as well, and yeah, easy, okay, no problem. Generally, probably for most GCSE projects at least, you're probably not going to measure peak load, but say if you've got a motor that might be pulling a certain large amount of current when it first turns on, then you might want to specify your power supply. So if anyone thinks they want to do something like that, have a word with me, and we'll talk about it in more detail. It's quite a good thing though to specify what the total draw on your circuit will be, or it should be less than. So for example, if I was making a circuit, I might think, oh well, I want that circuit to run off batteries. I don't want the batteries to drain drain down very quickly, so I want to limit, or I want to cap the maximum current draw of my circuit, and then in specifying that, then I'm going to then limit, I'm going to select certain components and select certain sort of technologies in preference to other ones to limit the circuit total current draw. So you could easily do that. And if you capped it, so honestly, for the majority of student projects which are involved in microcontrollers and a few potential dividers and a few LEDs and buzzers and things like that, probably, yeah, 150 milliamps will be fine. If you configure your LEDs right, they're probably only pulling about between about 5 and 10 milliamps per LED. Okay, trivial. Microcontroller pulls absolutely nothing, and buzzers as well, like 10 milliamps or something. So just add all of those together. Okay. Yeah. So if you decide that you want to have your device powered by an external AC supply, which then you're going to rectify, which means convert from AC to DC, and then maybe smooth with capacitors, and then regulate the voltage so it stays a constant voltage. Yeah, you can do that, and you can specify that as well. You could also mention about how much ripple after smoothing, after voltage regulation. So once again, if so A-level students know pretty much what I'm talking about, or hopefully they do. GCSE students, if you have more questions about that, then just ask, okay? Circuit will include short circuit protection. That's so easy to say, and it's like functional. It's not just like component thing. I mean, if you said it will have a fuse, then no. But if you say it will include short circuit protection, then yeah, you can do that. And how? Well, you might include a fuse. You might include a linear voltage regulator like an L7805, which has built-in short circuit protection. So lots of different ways. Reverse bias protection, stick in a diode, so easy, okay. Visual power on indicator, yeah, have an LED, which when you turn your power supply on, yeah, it's easy, okay. Let's say that you had, for inputs now, let's say that you were doing some sort of electronic system where it was like simulating withdrawing money, like an ATM type thing. Well, if you press a button and you press it once, you don't expect maybe for it to withdraw once. But actually, mechanical switches, they have this habit of bouncing, so it might, even though you think you pressed it once, it might seem like it's been pressed like 90 times, I kid you not. So if you're going to have a switch that might do something like that, you might need to debounce it either through hardware, that would be a resistor and capacitor most likely, or in software. So both A-level and GCSE students should know about that. If you're a GCSE student and don't know about it at this moment, then it's going to be covered shortly, okay? You could also say something like a single press of your reset switch will reset your counter to 0. Yeah, okay, so all of these things, yeah, motor speed will be controlled by 2 digital inputs. One will go faster, one will go slower, okay? Easy, okay, is not subjective at all. Maybe if you've got some sort of table lamp, you could specify that it's going to be controlled by an analog input. Don't say, I prefer you not to say by a potentiometer or a rotary potentiometer or something like that. This one actually is getting a little bit like just specifying like the component, but not quite. Okay, we are saying analog, we're not saying the actual component. Yeah, there's so much stuff here. Look, if you got something that counts, or like a game or something, and it's got a score, you'd expect it to start at 0, wouldn't you? Or probably would. If you do, then state it in the design specification. You know, my game score will start at 0 when the device is switched on, or my lives will start at 3 when the game starts, or you know, whatever it is. If you've got a counter that counts goals, then presumably each time a goal is scored, it's going to increase by 1. So specify it. That is a measurable thing, isn't it? If you get an incorrect answer, if you've got some sort of challenge, then, you know, every time you get it wrong, presumably your score is going to go down by 1. So state it. You know, this is, you know, like the performance, the operation. I should have written function as well there, actually. So, you know, the design specification is what the function it will do, okay? Yeah, if you're doing car speed, you know, how many digits you want, we'll specify it. If you're showing fan speed, maybe you don't actually want RPM, you just want to see some sort of like bar graph, like, you know, with maybe one LED, you know it's not very fast, but a load of LEDs, you know it's fast, so it might be more appropriate. So put it in your design specification that it will be indicated using a progressive bar display. Now, don't be specific, don't say LED, because it might not be LED. You could use lamps, you could use LEDs, you could use an LCD display. There might be something I can't think of off the top of my head. It's some other way for a progressive bar display. Power on self-test, this will be the last one I say about, okay? I think most student projects that have a microcontroller would strongly benefit from having a power on self-test. So when you turn the device on, it checks all the keys or the buttons or whatever they are, and checks that they're in the state that you would expect them to be. And so, like, if someone's left a book lying on top of, say, one of the switches or something, or the key is stuck in because it's just like a dodgy contact or something like that, then maybe it sounds an alarm or something like that, okay? And then also with the outputs, I would get it to cycle through, like, you know, like counting out some numbers or illuminating the LEDs in sequence or something like that. So I would strongly recommend stating that the device will include a power on self-test for the inputs. The device will include a power on self-test for the outputs. And, you know, that's two design specification points that you will have there and be able to achieve, even if you aren't able to write the rest of your code for, like, the game or whatever it is you're doing. But you will have established that you're able to communicate, you're able to configure those ports for inputs or outputs, and you're able to communicate with them, which I think is really good achievement. Okay, that's it. All right, nearly half an hour. That's unbelievable. I just know that you're not going to watch this, are you? Not in full, anyway. But if anyone does, yeah, I'll maybe buy them a bar of chocolate or something. Not really, because I don't do that. But yeah, I will congratulate you for your perseverance. Okay? Do give it a thumbs up. Thanks very much then. Bye.